Now we're ready to prove Witt's theorem. Witt's theorem says that quaternion algebra are uniquely determined by their conics. Two quaternion algebras are isomorphic, as K-algebra, if and only if their conics are isomorphic. For simplicity, let us call this conic C1, this C2, and this quaternion algebra Q1, and this Q2. Then observe that the conics are isomorphic if and only if their function fields are isomorphic. Because for smooth curves, being isomorphic and being birational are the same things. The necessary direction is clear, so we want to prove sufficiency. So let's say that the two function fields are isomorphic. We want to show that Q1 is isomorphic to Q2. Now, if the two function fields are isomorphic, then the two restriction maps are going to be the same. Because recall that the maps just sends any Savory-Brow variety to the fiber of that variety over the function field. In other words, the two maps will have the same kernel, so we see that this kernel C1 and C2 generate the same subgroup in the Brow group. This is a subgroup order 2. Now, if one of them is trivial, right, then that means that C1 splits, so KC1 is rational and so must KC2. So then C2 will also be trivial. Thus, they are either both trivial or both non-trivial. And since there is only one non-trivial element in this group, we must have that the class of C1 is equal to the class of C2. But previously, we have shown that the CIs are just the Savory-Brow varieties of the QI. So this means that the class of Q1 must be equal to the class of Q2. Now be careful here because we are not done yet. What we have shown is that Q1 and Q2 are Brow equivalent. We have yet shown that they are isomorphic. So why are they isomorphic? Well, that's because they have the same degree. Or equivalently, because they have the same dimension over K. So let's review why. Remember, there is a unique division algebra in the class of QI. By Wedderburn's theorem, we even know more. We know that Q1 is going to be a matrix algebra of this, and so is Q2. Now, for Q1 and Q2 to have the same degree, or equivalently the same dimension over K, then we must have M must be equal to N. And so in that case, we must have that Q1 and Q2 must be isomorphic to each other. Thus, we have for quaternion algebras, they are isomorphic if and only if their corresponding Savory-Brow varieties, the conics, are isomorphic.